4.6 on quadratic formula. So the quadratic formula is in the top corner there. First you need to check to make sure it's in standard form, which is that form there. And this is the quadratic formula. So lots of A, B's, and C's. Miss Yaney said you might have learned this lesson over the spring virtually. So I'll make sure to write out all the work so you understand it. So first we have x squared minus 10x equals 11. You have to use the quadratic formula now to solve this. So we need to get the 11 over to the left side, so you're going to subtract it over. So it's equal to 0. Now from here, it's helpful to list your A, B, C coefficients. I like to go off to the side, do a little box. So the A value is right here in front of the x squared, so that's 1. The B value is a negative 10, and the C value is a negative 11. So list your A, B, C's. Now all we have to do is substitute those correctly into the formula. So this starts with an x equals a big long fraction bar, negative B. So when it says negative B right here, that means a negative of whatever your B term is, and since ours is a negative 10, a negative 10 changes to a positive 10. There's a plus or minus sign in the middle, a longer square root. B squared, so put negative 10 in parentheses and square it, minus a 4 times the A value, which is a 1, times the C value, which is a negative 11. And on the bottom is 2 times A, so 2 times 1. So that's with everything substituted in. I'd like to see another step here, 10 plus or minus. Now for this one, I'll show you in a couple pieces. Negative 10 squared is 100. And then negative 4 times 1 times negative 11 is a positive 44. And the bottom 2 times 1 is 2. So now you have 10 plus or minus. 100 plus 44 is 144 divided by 2. We can take the square root of 144, which is 12, and put it over 2. So here's where you can break this off. 1 gets the plus, 1 gets the minus. So let's do the first one with the plus sign. 10 plus 12 divided by 2. So that's going to be 22 divided by 2. So one answer is x equals 11. The second one, I'll go to a different color here, uses 10 minus 12 divided by 2. So this will be negative 2 divided by 2, which is a negative 1. So your second answer is a negative 1. So not very difficult, but just be careful on your negatives and how you substitute the numbers in. Okay? So the next example, I want you to try this one. Notice the heading says you'll get one rational root, and you'll see why once you start using the quadratic formula. So you try this one. It will ask in Delta Math for you to type in your final answer for this problem, but make sure you put the work in your note packet. All right, example 3 is irrational roots. So this is where you're going to have an unperfect square root, and you can, well, you'll see how we'll leave our answer and then we'll approximate it. So check, it's already in standard form, so I don't need to do that step. Let's list our A, B, C values. A is a 2, B is a 6, C is a negative 7. So x equals, big long fraction bar, a negative b, so that's going to be a negative 6 this time, plus or minus the square root of b squared, so that's 6 squared, minus a 4 times the a value of 2 times the c value of a negative 7. All over 2 times the a value, which this time the a value is 2. So now let's simplify. We have negative 6 plus or minus. 6 squared is 36. 4 times 2 times negative 7. That's going to change to plus 56 all over 4. (36 plus 56 is 92. So we didn't need all that. Alright, the square root of a 92, if you go off to the side and simplify that, that's going to be 4 times 23. So that's going to be 2 root 23. If you simplify that. And notice our coefficients, well, one, our square root is 23, which is not a perfect square root. But these numbers here are all divisible by 2, meaning you can divide them all by 2. So this turns into a negative 3. 2 divided by 2 is a 1, so this is just the square root of 23. 4 divided by a 2 is a 2. So you can leave your answer like this. If you had to approximate them to the nearest tenth, you could type this directly into the calculator, negative 3 plus the square root of 23, and then divide by 2. And then the second time use the minus, and you'll get x is approximately negative 3.9 and approximately 9/10. So those would be your decimal approximations. So this one has complex roots, meaning you're going to have an I in your solution. And again, I would like you to try this one in your packet, and Delta Math will ask for the answer. So there's the second problem for you to try. All right, discriminant. This is different from the determinant with matrices. A discriminant is the part of the quadratic formula. That's just the part underneath the radical sign. So the b squared minus 4ac part. So if it's a perfect square, like the square root of 25, you're going to have 2 real rational roots, like the first example I showed you. If it's not a perfect square underneath the radical, say like the square root of 63, you're going to have 2 real roots, but they're going to be decimals or irrational numbers. If you get the square root underneath as a 0, then that whole half of the problem cancels out or just disappears, meaning you're only going to have 1 real root. And if it's the value underneath your radical is a negative, so like negative 3, you're going to have complex roots, and this is where you have the I, imaginary numbers. You can see on the graph there, it never crosses the x-axis, meaning it has imaginary solutions. So describing roots, find the value of the discriminant for each quadratic equation, so we need the value of that. Then describe the number and the type of roots that you'll have. Okay, so I'm going to do letter A, and you're going to try letter B on your own. So it's in standard form. Let's list the ABCs. A is 7, B is negative 11, C is 5. And we have to do only the b squared minus 4ac part. So b squared, well, that's negative 11 squared minus a 4 times a 7 for A. C is 5. So negative 11 squared is 121 minus 4 times 5 is 20 times 7, which is 140. So I'm going to get a negative 19. That is the value of the discriminant, which means you would have a negative under your square root, which means you're going to have 2 complex roots. So they're going to be imaginary. So I would like you to try letter B. Find the value, list your ABCs, then figure out what the value of b squared minus 4ac is. And then be sure to tell me what type of roots you'll have. So use the chart. Will you have 2 real rational roots, 2 real irrational, 1 real rational root, or 2 complex roots? So you'll need to answer that question in Delta Math. Then finally in your notes you have this amusement park ride. I know I always scream on these, even the one at Del Grosso's. But try this one. You can use the quadratic formula to figure out about how many seconds does it take for riders to drop from 60 feet to 0 feet. And you can round that to the nearest hundredth.